I'm Alessandro Franceschi. I'm using Puppet for 5 or more years. I'm doing modules, example 42 modules, maybe some of you knows them. And I'm always working about modules and how to make them reusable. So I think that some of the points, especially here, are useful for everybody who wants to make reusable modules. Before beginning, please apologize me for the terrible Italian accent, for the fact that I probably won't understand your questions, if you will have questions, and for the fact that maybe you will fall asleep. And well, maybe it's not only my fault, maybe it's the chicken we have eaten at lunch, but anyway, let's see what happens. So, what's the main usage of Puppet we have to do? How do we use Puppet? We typically include classes, we set parameters, variables, we define inside our code some logic, our business logic. We provide configuration files to our hosts, and we manage resources. And all this is done using different components of the Puppet architecture. So, for example, we can include classes in the site pp file or in the ENC, or maybe also using Hera with Hera include. We set parameters and variables in different places, on ENC, on Hera. We can set them in our custom site modules. We shouldn't set variables inside shared common modules. And these variables with the classes which are related to the variables are somehow often integrated, glued together in some kind of logic which may be defined in a custom site module, in ENC, or also in site PP. And other components are the configuration files we provide. We provide them as templates or as static files. Typically, they are in modules, either shared or site modules. And also the additional resources we may decide to add to our modules. And also these ones can be defined in site modules or shared modules. So this is, let's say, the overview of where are the typical components of the Puppet code we typically use. Now, talking about a reusable module. According to me, a module is reusable really when it allows you to have total choice and freedom of choice on how to do things. So you can have the module that have to be work on different operating systems, that can work on different kind of infrastructures of different scales. It should be able to work with different node classifiers and with different methods to provide variables to the module. And also it should somehow, in some cases, provide alternatives, options on how to install the application the module provides. And also should be able to provide alternative setups of that typical application. So all this is about reusability, and all this is about choice. And of course, a reusable module has to be used as is, without any change in the module. Otherwise, it's not anymore reusable. It's something that has been forked and then adapted to custom needs. Now, actually, not always a reusable module is the best solution for every case. Because when you introduce reusability, you introduce abstraction and you introduce more complexity. You have more things to cope with in the module. So you need more verbosity in the module, and the same development is harder, longer, maybe more error-proof, can provide more errors, and so on. And also, if you look for performance and optimization, for sure, a reusable module is not exactly the best solution. So you may decide to have just the resources you want in your custom module, which does exactly what you need, and don't care anything, and of course they work only for you, and you don't have to care about reusability. So the point is, it's not always necessary to have reusable modules. But now we are talking about, we will talk about what could be the points to have in a reusable module. Now, when we talk about modules and reusability, actually we are talking also about the APIs that it exposes, the parameters that allows the users to set and use the module as they want. And this kind of parameters somehow cover different kind of areas of the module. So some of the parameters may relate to the resources that the module provides. Other parameters can be related to specific application options of the application that the modules provide. Other parameters may relate to the logic of the module, what you want to install, how do you want to install, and whatever is related to the application that the modules provides. And also sometimes you have to provide parameters in your module that somehow related to other modules, so the integration between different applications and so on. Now let's see some examples of these kind of parameters. For example, parameters that are related to attributes of the resources managed. You can define the name, have a parameter that sets the name of the package you are installing, or the configuration files you are managing, or the service you are managing. And you can also, you have to decide when you make a module what are the parameters which are somehow needed and what could be somehow redundant. So for example, some two specific parameters on options related to, for example, the owner, the group of a file which is managed by the module, may be too much to be exposed as a parameter. They may allow you to have more choice on how to set them, but at the same time they can grow your own parameters list. As a side note, what could be useful for this kind of parameters is a naming convention. We will talk about it later on. And so this is a point which is underlined there. Other kind of parameters are the ones related to the specific application you are managing with the module. And in this case, actually, you can get into a spiral of parameters prolifications. So for example, you may have legit parameters like the IP or the address of a syslog server or a Mooning server, whatever. But if you start to add one parameter for each application option you may have in your module, you can have parameters like all the ones set there and many more, which actually can be a never-ending quest. I mean, for any kind of specific application option, you may have a parameter to set it, and this could grow in quite an uncontrolled way. So in order to cope with these kind of problems, we'll talk about a sort of approach based on template and options hash, which can be useful to leave total freedom to the user to define as data the specific parameters of application without having a module full of parameters that manage all of them. Also, the same, let's say, application logic managed by the module can be defined by parameters. So if you want to install only the client, the server, if you want to have your service restarting when you change your configuration files, if you want to initialize a DB when you install a specific module or whatever. These are somehow some of mixed kind of parameters which somehow relate to what the module does when you install it. And this is quite an open space for any kind of possible alternatives. And also here, maybe some benefits can be achieved with using some kind of standard naming. And finally, what I say, modus integration, when you have to refer to resources provided by other modules related to other applications inside your own module. And here also there can be many different parameters that can be added. And for this, I will talk about, let's say, some kind of higher level modules, which I call stacks, but anyway, something which is quite common. So, let's get into some patterns, typical patterns about reusability in a module. I will show you some code examples, and we will see what we can do with them. Typically, when you use Puppet, 90% of the time we manage files, configuration files or applications and so on. And actually, reusable modules, according to me, should leave total freedom to the users on how to provide these files. We can have different options. We can provide ERB templates. We can use the source attribute to provide a static file. We can compose configuration files using concat or OGAS or custom types or whatever. According to me, a reusable module should allow any of these alternatives. Now, how this can be done in a practical way? This is an example, for example, where you can set for the main configuration file of this Redis, for example, the source to use, or the template, or more largely the content of the file, so what is going to be used in the content attribute of the specific file. So this piece of code is just an example on how you, by default, don't set any of these source possibilities, but you can manage any of them in some kind of way. And the usage for the user is something like this. If you want to provide the configuration file as a template, you can pass the file template parameter. If you want to provide it as a content, maybe using inline templates or whatever, or specifically using the content, you can use file content. You may use file source to provide a specific single configuration file, static configuration file, or an array of files according to whatever kind of logic you want. Or, in this case, if you want to manage your configuration file in some other way, which is not actually explicitly managed by the module, you can just do not specify any specific option. The module does not touch the configuration file, but you can manage it in the way you want. So this could be an approach, an example on how to use different, how to leave different options on how to configure and set files for a specific application. Most of the times you need also to configure not only one configuration file, but many configuration files for applications. And here you can find different approaches and different alternatives. You can add parameters to your own main class to manage all the specific attributes of the extra files you have to manage. You may use a generic conf define or also the whole configuration directory. Let's see these examples. This is a way how you can add parameters to manage different configuration files and their content and so on. This actually doesn't scale too much because if you have many different files, you have many different parameters to be added. So could make your list of parameters grow too much. This will be an example of usage of this pattern. Another approach can be to have a sort of generic conf define, which just allows you to define the path of your configuration file, the content, and it places the file where you need it, using, let's say, all the parameters and attributes which are relevant to the module, so the default username, owners, group, and so on. And in this case, the usage could be something as easy as this. So the name of the file, by default, this name is placed in the default configuration directory, and the template from where to get the file. And this is quite an easy define that you can add in any kind of module and allow users to manage independently any kind of configuration file. Another approach to manage multiple files could be the management of the whole directory of the configuration. So an option like dir source, which can be used to as a source attribute in the whole directory. And you can also add a sort of dir purge option to allow, let's say, full mirroring of what is defined in the source compared to what is actually deployed in the destination directory. So this will be an example of usage setting a dir source without deleting any existing file, or with the dir purge set to true, you can have exactly the content on the defined directory on the Puppet master copied to the destination directory on the node. And this can be an approach to manage a bunch of files, of configuration files in a very strict and, let's say, hard-coded way. Different approaches for different needs. More or less, they can all also work together in some cases. Another point is managing users. Actually, we all typically manage the users we place in our systems in different ways. Maybe we have our own ways to manage users. So when a module requires a user for its application, according to me, it should leave the option to the users of the module to override the way the modules creates these users. So this can be an approach. You can have a user parameter and, for example, a user class, the name of a class where the user is managed. So who is the user of the module can define an alternative class where the required user is created in his own ways, or just a no class, so avoid the usage of the creation of the user used by module, and leave, for example, LDAP users and something like that. So the point is, when you have to manage users related to the application you install, you should allow freedom to override the user creation managed by the module itself. Also, many times you need to add resources to your own applications. For example, you may want to have your Apache document root in some other place, so you have to create the directory where you want to place your documents and so on. And it's actually resources that you have to add to your module, which are related to your Apache module, but you can't expect an Apache module to provide them, of course, since they are very custom and very local. In this case, you can have different approaches. According to me, you can also you can use this, let's say, class, a parameter that lets you specify a class to use and where you can add specific resources related to the module. And in this case, for example, you may use also, you may provide a custom class where you provide the same, some kind of dependencies of the module, which maybe are related to other applications, which maybe are related to the usage of a specific module of which manages those applications. So you may leave the user to set his own class where the same resources are managed in a custom way without having the need to manage dependencies between modules and looking for different module set and so on. Another approach to provide alternative resources to a module can be to use the create resources function in stdlib, and so have some option, some parameters that lets you define the type of the resources you want to manage and then hash with all the attributes of these resources. So these are just ideas possible for to manage any kind of extra resource you may want to add to your application with just simple parameters which can be used as anyone can prefer. Also, typically, we can have the need to set and to use specific packages or specific service names. And since it's quite common to have, for example, people managing their own packages, it can be useful also to have modules that allow you to manage that kind of packages even if they are not the official ones. So, for example, you may have simple parameters just that let you set the name of the package to install and leave to the users the possibility to set to install, for example, an OpenSH package using a customized package with a different name and still using OpenSSH module. So this will be an example. You can have also the possibility to, for example, still having your own choice of which are the default names of the package for different operating systems, but leaving the user the possibility to override them. This works for packages, this works for services, it's the same logic. The point is leave freedom to choose and to override default settings. And this is an example of usage. Also, sometimes you may have the need to install an application not using the typical package. So a reusable module may have the option to the option to allow users to specify how to install an application. Now, this can be useful for some kind of, let's say, new applications like Elasticsearch. Maybe it's not so useful for well-established application for which you will never take the tarball from the source site and use it. You will use your operating system package. But in any case, for example, for these cases, it can be useful to have some kind of option, install, or whatever, where you can set how you want to install that application, using the package provided by the operating system, getting the upstream tarball and unpacking it, and this is all about choice. So leave users the choice to decide how to install their own application. This will be an example of how to install Elasticsearch, getting directly the zip from the upstream site. We have talked about the parameters that are somehow related to the specific configuration options of an application and how these could be managed using templates and option hashes. So let's see what is the example. You may have a parameter which defines the template to use, and also a parameter which allows users to provide an options hash. And this hash can be used in a ERB template with either this function options lookup, which actually is something that is included in my own set of modules, and maybe it would be like to have it in the standard lib, something, a specific option, a function that looks for the key of an option in the options hash and provides a default value given if the key is not, if no explicit option is related. Or maybe you can use directly a scope lookup var and then set an alternative default set. It's important to define a default setting because you may have an option hash with not all the parameters of the application you manage explicitly set. So defaults are always useful. So this can be a pattern to manage with just 2 parameters any kind of possible application-specific configuration item. And the usage is either using directly a parameterized class or here with the YAML where you can set all the parameters you want. So this is a usage case using different. When I talk about parameters, actually, I don't necessarily mean that you need to provide them in a parameterized class style. You can, of course, set the same parameters using data bindings in Puppet 3 and having them set in here. Now, I've talked about naming standards, which can be useful to manage and to parameters who are typically related to application to resources options and so on. There has been some discussions about this naming standards initiative. There has been a blog post I wrote, some discussion on Puppet users. There is a GitHub account where some examples are provided and some exploration is done on the name of the parameters we can use. The aim of this initiative is to try to define some kind of naming standards, nothing more, nothing less, about parameters of modules. So if you want to relate to a specific kind of parameter, it doesn't make sense to have this name different in different modules. If there is some kind of agreement on what could be the same name for this kind of parameter, it will make life easier for everybody. So I invite you to go on GitHub, Stdmod, eventually join this discussion ongoing because it's still a draft. We are discussing about what could be the names of these parameters and so on. So just to show you some examples of what we are talking about, before just a small slide about what are the benefits of standards. I think they are quite obvious. Once you have common standards, you may have users who can use different modules more easily and switch from one to another. They know that they can use always the same standard, for example, template, to provide your own configuration template. So, I mean, you don't need to explore the module code or read the documentation to know how to provide your own template for the configuration file. At the same time, it can be useful to have standards, because once you need to add the features to your module, you may already know what are the name of the parameters you have to add, because there is a standard which is somehow setting them and suggesting them. Also, some standards naming can be useful to improve the reusability of modules, because if you suggest some naming standards that, for example, employs these kind of, the examples we have seen before of parameters that can leave users options to decide how to manage files, manage users, and so on, automatically a module that uses this naming and these kind of parameters probably has more reusability options, and so can be useful also for this kind of approach. So we were talking about what could be these naming standards. So nothing particularly new. I mean, some kind of these names of parameters are already common sense, already used. So there is already some kind of convergence of some namings. On some other names, maybe the discussion can be more, there are different options. The point is, for parameters that relate to attributes of a resource that a module uses, a good pattern is just to set the name of the resource and the name of the option you are managing. So this is clear that these parameters relate to the options that are used by the service that the module provides. Then there are some different alternatives which actually, according to me, should be somehow defined on how to, for example, give names to the main configuration files or the configuration files you are managing. So, for example, you have to provide the parameter that allows you to set the source of your configuration file. How do you call it? Files underscore source, source, config file source, config source, whatever. I mean, the discussion is still growing, and there is not yet a strict, let's say, standard set. So, but the point is that actually there is not so much to discuss about. Most of the things are quite clear and quite defined. And also, for example, when you have to define, to have a module that provides various kind of services, various kind of packages, it may make sense to have a prefix with a specific to the resource, the name of the resource, and then the usual pattern with all the possible attributes you may have to set for the resources. Also, for installation, it will be useful to have a naming standard so that you can, okay, you want to install your Elasticsearch using the upstream tarball, install upstream, install source, whatever kind of naming, but the point is, once that is set, that can be shared and reused by people as they want. Note that all these possible parameters names are not necessarily needed for any kind of module. I mean, you may have your own modules using parts of these where needed and ignoring most of the others. The point is, let's give names to possible parameters that you may have in your modules. Then, if you have these parameters in your module, the idea would be use these names for the parameters you need and you want to use in the module. And the same thing for things like monitoring and firewalling, which are somehow still to be, let's say, not so much spreaded as concepts, as parameters you may set in modules to explicitly define how to monitor or firewall the resources provided by the module. Now, another point, which somehow relates to how we use modules when they have and they cover different applications and they have somehow to manage integrations between different applications. I call them stacks. Actually, it's nothing new. We are using stacks every time in our site modules, in our role classes, in our custom classes. The point is, in current Puppet setups, you don't just install one application and you manage it with the module. You have different applications building an upper stack. And so the point is, we are still, everybody, reinventing the stack. We are still gluing different modules in our custom classes and making them behave together to provide what we need. So it will be, according to me, quite interesting to start to discuss about this kind of higher level modules, this kind of stacks or whatever we can call them, and try maybe to find some kind of standardization also there, explore best practice on how to expose to an higher level all the configuration options which are related to a whole stack of applications. And I think we are still at the beginning of this process, but it's time to think seriously about it, because we are looking more and more people doing the same things in their own ways, maybe sometimes finding by mistake what could be a good solution or not. And so,
is it sort of like the roles and profiles talks that were going on?
Yeah, I mean, you typically use stacks in roles and profiles, but in roles and profiles, in the article about that, it's explained that you can organize your code using profiles and roles. But my point is, let's start to think about actually what specific stacks, how they can be, what parameters they can expose, how they can be standardized maybe, or at least what can be the good practice on how to organize this kind of code. So the point is exactly that anyway. We use stacks in roles and profiles. So this is just an example. It's an attempt I tried to define a stack class. In this case, the module is called stack, but it doesn't matter, which manages the logging infrastructure of a set of on a Puppet setup, where you can have different options, because the point is to provide an higher level abstraction, so provide parameters, APIs, which you can use to set what you need to configure all the lower levels modules and applications. So these are some kind of possible parameters. One of the most important things, according to me, is always leave the possibility to override the default templates or configuration templates which the stack provides. So users can always have the option to set their own, provide their own files. In this case, then you can have something like this. So, for example, to manage your whole logging setup, you may have on any kind of server just set the syslog server, what you need. And that will install your syslog and throw logs to the specified syslog server. Then you may have your syslog stash collector, which acts as a syslog server. Actually, this specific stack is based on a, let's say, specific layout, architectural layout of a logging infrastructure. Nodes, syslog central with logstash getting all the logs, saving them to Elasticsearch and having a Kibana server to expose the logs and have a graphical interface to them. So the point would be, in this case, on any host, you just specify the syslog server and you install the rsyslog configuration or whatever. On the logstash server, you install logstash, set a parameter which says, okay, this is the Elasticsearch server, throw your logs there, and nothing more. On the Elastic server, you may need to add more options, and of course, here, as in any other place, you may override the default template that the stack provides, because, of course, a stack, when you install a module, you may have, okay, the module installs Apache and doesn't configure anything. Package present, service running, file, configuration file as is. When you want to have an higher level abstraction, you have to introduce real configurations. You have to modify files. So the stack module has to provide working configuration files where all the integrations are done. But the point is, leave users the option to override these configuration files and provide their own versions of the templates or whatever. And then, for example, also on the Kibana server, you may have install Kibana true, and there will be the Kibana module installed, and so on. So, for example, the code inside your stack is something as simple as, okay, if installing Elasticsearch is true, then I manage Elasticsearch with all the parameters I may want to add. So this is an example. There are probably much better examples around, but the point is, let's start to discuss about this. Let's start to see what could be the sane ways to have provide higher level abstractions to the modules we provide and we use. So, just to be clear, stacks are somehow local, are quite specific. Maybe you may have to modify your stack class to adapt it to what you need. Modules are supposed to be shared, reusable, not touched, and so on. Stacks provide an higher level interface, and somehow they can provide some kind of way to integrate a different set of modules. You may have your stack, which has inside declarations of classes, which may change according to the modules you want to use. But if there are some naming standards, maybe you don't even have to change your stack's code, because all the modules may behave in the same way, at least for those parameters. Also, this kind of usage of stacks may help you in avoiding the need to change modules to add your own stuff. So voice is going, but at least we are in the end. So how do all this copes with our sample of different kind of Puppet components? In this way, more or less. Stacks can cover integration logic, provide configuration file, provide extra resources. This is their own place. They can live and work together with the other components. These are not alternatives. We can organize things with different patterns, but that's the place for stacks. And also in this case, could be nice, useful to define some kind of standards, to provide some, or best practice, to provide some higher level APIs, which could be used also by graphical user interfaces. So this is everything about this can be discussed and explored. So that's the point. Next steps, what we can do in the future. Define naming convention for modules, but explore also stacks and best practice about stacks and so on. And also explore GUI integrations, because once you have a stack, you have what the user need at the end. Maybe just the way to provide the possibility to give some options and then with them configure whatever they need. That's it. I just would like to show you that graphics, the wonderful graphics we are seeing here are made by this great guy, tatlin.net, is his site. And well, if you have questions, we have not so much time, 45 seconds, but
So when I've been writing modules myself, the more options that you add, the harder it is to test. How do you unit test something that is so reusable?
well, in the past, I've been quite excessive in setting parameters. If I had to rewrite some of my modules, personally, I would cut many of the parameters, even if most of them were for reusability patterns. And to be honest, I don't test all the parameters for my modules. So the solution is, how do you do? You don't do it.
What's the best way to do it?
Well, actually,
Is there one of your modules that you would
Well, the example 42 sets, they are sending me to jail, stop everything. I will ask you, I will reply you privately.
Sorry, we're just out of time.
Okay.
Thanks so much for attending the talk. Alessandro, thank you for speaking with us.